Dear children, welcome to this channel. In this video, let us see the examples and the exercise under the topic nature of the roots of the polynomial equation. First, let us see example 3.11. Show that the equation 2x squared minus 6x plus 7 is equal to 0 cannot be satisfied by any real values of x. See, what does this question means that this equation has a solution as imaginary. You have to show that the equation has imaginary values, imaginary roots, okay. That is the meaning for it should not satisfy by any real values of x. So what is the condition for a quadratic equation to have negative roots, imaginary roots? Delta must be negative, okay. So let us see what would be the value of delta. So given equation is 2x squared minus 6x plus 7 is equal to 0. So delta is nothing but b squared minus 4ac, where a is 2, b is minus 6 and c is equal to 7. So this delta value is minus 6 the whole squared minus 4 into 2 into 7, that is 36 minus 56, it is minus 20, which is a negative quantity. So as delta is 0, the roots are not real. Then example 3.12. If the equation x squared plus 2 into k plus 2 into x plus 9k is equal to 0 has equal roots, find k. So when the quadratic equation will have equal roots, if its delta value is exactly equal to 0. So let us equate this delta to 0 and find the value of k, okay. So the given equation is x squared plus 2 into k plus 2 into x plus 9k equal to 0. So what is the value of a in this case? 1, and b is equal to 2 into k plus 2 and c is equal to 9k. So delta is equal to b squared minus 4ac. The value of b is 2 into k plus 2. So 2 into k plus 2 the whole squared minus 4 into a is 1 and c is 9k. So 4 into k plus 2 the whole squared minus 36k. So this is delta. But for equal roots, delta is equal to 0. So this implies that 4 into k plus 2 the whole squared minus 36k is equal to 0. So dividing by 4, we have k plus 2 the whole squared minus 9k equal to 0, or expanding k plus 2 the whole squared, we have k squared plus 4k minus 9k equal to 0, or k squared minus 5k plus 4 equal to 0. So if you factorize it, it will be k minus 4 into k minus 1 is equal to 0, or k is equal to 4 or 1. So for the value of k as 1 or 4, the equation will have equal roots. Then example 3.13, show that if p, q, r are rational, then the roots of the equation x squared minus 2px plus p squared minus q squared plus 2qr minus r squared is equal to 0 are rational. Okay. So what is the condition for rational roots? Delta must be positive and also a perfect square. Okay. So here given equation is x squared minus 2px plus this p squared minus q squared plus 2qr minus r squared is a constant term equal to 0. So here what is a? A is equal to 1 and b is equal to minus 2p and c is equal to p squared minus q squared plus 2qr minus r squared. So for the roots to be rational, it should be perfect, delta should be perfect square. So let us find out delta. So delta is equal to b squared minus 4ac. So b squared, that is minus 2p the whole squared minus 4 into 1 into c is p squared minus q squared plus 2qr minus r squared. Okay. So this will be 4p squared minus 4 into, let us multiply 4 throughout. So we have minus 4p squared minus 4 into minus q squared is plus 4q squared, then minus 8qr, then plus 4r squared. And here these two terms get cancelled. Again among the three terms, let us take 4 common outside, so that you will have q squared minus 2qr plus r squared will be the terms inside. So this is nothing but q minus r the whole squared. Okay. So we can write this as 2 into q minus r the whole squared. So which is a perfect square. So whatever it may be, that is q minus r, whatever the values of q and r, either it q minus r will be positive or negative. On squaring it's going to be a positive quantity, and moreover whole square means it is a perfect square. That means that delta is a positive quantity and also a perfect square. That is greater than 0 comma a perfect square. And this implies that the roots are rational. Okay. Next example is example 3.14. Prove that a line cannot intersect a circle at more than 2 points. That means that you have to show that a line intersects a circle exactly at 2 points. So in order to show, let us take a circle equation and a line equation, straight line equation. Okay. So let y is equal to mx plus c be the equation of the straight line. Let it be equation 1, and x squared plus y squared is equal to r squared be the equation of the circle. Okay. To get the point of intersection of the line and the circle, we have to solve the two equations. So what are the two equations? Y is equal to mx plus c is the first equation, and x squared plus y squared is equal to r squared is the second equation. That is equation of circle, and this is equation of straight line. So in order to find out the points of intersection of these two, you have to solve the two equations. One is linear and other one is a second degree equation. So how to solve in such cases means you have to substitute the value of y in here. Okay. So second equation implies x squared plus mx plus c the whole squared is equal to r square. That means you have brought a quadratic equation is single variable x on substituting y here. Okay. So let us expand and simplify it. X squared plus m squared x squared plus 2mxc plus c squared minus r squared is equal to 0. That is x squared plus m squared means taking x squared common, we have 1 plus m squared plus 2mcx plus c squared minus r squared is equal to 0. That is, rewriting in the proper way, 1 plus m squared into x squared plus 2mcx plus c squared minus r squared equal to 0. So on solving 1 and 2, we had a quadratic equation in x. Okay. So the resulting is, which is a quadratic equation in x. So how many values do you get if you solve this? You will get 2 values of x. On substituting the 2 values, you will get 2 values for y, and hence we get 2 points of intersection. This shows that the line and the circle intersect only at 2 points. Okay. So this gives 2 values for x, in turn 2 values for y. Okay. This implies that the line and the circle intersects at 2 points. So they won't intersect at more than 2 points. Okay. Now let us go to example 3.8. Find the monic polynomial equation of minimum degree with real coefficients having 2 minus root 3i is a root. Okay. So you have to find the equation of minimum degree. One root is 2 minus root 3i. So complex conjugate with minimum degree means it will be a quadratic equation. Okay. So one root is 2 minus root 3i means the other root would be 2 plus root 3i. You know that complex roots occur in conjugate pairs, right? So given 2 minus root 3i is one root. So this implies that 2 plus root 3i is also a root by the theorem, complex conjugate theorem. So let us find out first sum of the roots. To find the quadratic equation, given the root, let us find out first sum, that is 2 minus root 3i plus 2 plus root 3i. So 2 plus 2 4, and these two get cancelled, and then let us find out product of the roots. Product of the roots is 2 minus root 3i into 2 plus root 3i. So they are conjugate to each other. So therefore it is real square plus imaginary square, that is 2 squared plus root 3 whole squared, that is 4 plus 3, which is equal to 7. And therefore the required equation is x squared minus sum of the roots into x plus product of the roots is equal to 0. So that is x squared minus 4x plus 7 is equal to 0. The next example is example 3.9. Find a polynomial equation of minimum degree with rational coefficients having 2 minus root 3 as a root. Given 2 minus root 3 as a root means it is irrational. So minimum degree to have irrational root means it must be a quadratic equation. So what would be the other root? It should be its conjugate, that is 2 plus root 3. Okay. So taking 2 plus root 3 to be other root, we can find out the required equation. So given 2 minus root 3 as a root, this implies that 2 plus root 3 is also a root. Okay. Therefore, let us find out the sum of the roots to get the quadratic equation. Sum of the root is 2 minus root 3 plus 2 plus root 3, that is equal to 4. Then product of the roots. Product of the root is 2 minus root 3 into 2 plus root 3. So it is of the form a plus b into a minus b. So a squared minus b squared, that is 4 minus 3, which is equal to 1. And therefore the required equation is x squared minus sum of the roots into x plus product of the roots is equal to 0. So that is x squared minus sum of the root is 4. So 4x and product of the root is 1. So 1 is equal to 0. Next example 3.10. Form a polynomial equation with integer coefficients with the square root of root 2 by root 3 as a root. Okay. So this is an irrational root. So using this we are going to get a polynomial equation whose coefficients must be integers. Okay. So as a square root of root 2 divided by root 3 is a root, x minus of square root of root 2 by root 3 is a factor. Okay. And then its conjugate will also be a root, and this implies that x plus root of root 2 by root 3 is also a factor. Considering its conjugate as a root, we can have x plus root 2 by root 3 is also a factor. So let us multiply these two to get the equation. Okay. So x minus of square root of root 2 divided by root 3 into x plus square root of root 2 divided by root 3 is equal to, okay. So it is of the form a plus b into a minus b. So it is will be equal to a squared minus b squared, that is x squared minus root of root 2 by root 3 the whole square, means simply we have root 2 by root 3. Okay. But this still it is not a required equation, even though it is a quadratic equation, but it is not the required equation with the integer coefficient. So here the constant term is irrational. So again you have to remove this. To get rid of this irrational coefficients, you have, let us take that this is one factor and this would, there will be another factor with the plus sign. Okay. So this implies that x squared plus root 2 by root 3 is also a factor. Still we have not reached the integer coefficients. So the polynomial equation is not of degree 2, it may be of higher degree. So what you have to do, considering this as a factor, there will be another factor with its conjugate, that is positive sign. So this implies that x squared plus root 2 by root 3 is also a factor. So again you have to multiply these two to get the required equation. So x squared plus root 2 by root 3 into x squared minus root 2 by root 3 is equal to, Again this is in the form a plus b into a minus b. So a squared will be x squared the whole squared minus root 2 by root 3 the whole square. That is x power 4 minus 2 by 3. Okay, x power 4 minus 2 by 3. So this is 3x power 4 minus 2 divided by 3. Now, so if it is equated to 0, so therefore the required polynomial equation is, so we have found out the product of the factors. So if it is equated to 0, we will get the required polynomial equation. So the required polynomial equation is 3x power 4 minus 2 by 3 equal to 0. That is 3x power 4 minus 2 equal to 0, which is a quadratic polynomial. Now let us see the exercise problem. Exercise 3.2, the first one is, if k is real, discuss the nature of the roots of the polynomial equation 2x squared plus kx plus k is equal to 0 in terms of k. That means you have to find out for what values of k this equation will have equal roots, distinct root and imaginary roots. So that is the question. Okay. So you have to find out the value of k for what, for which, where delta is equal to 0, delta greater than 0 and delta less than 0. So for that let us find out delta first. So given equation is 2x squared plus kx plus k equal to 0. So here a is equal to 2 and b is equal to k and c is also equal to k. So the delta value b squared minus 4ac is equal to k squared minus 4 into 2 into k, or k squared minus 8k. So let us factorize this by taking k common outside. So we will have k minus 8. So using this we are going to determine the value of k for which delta is equal to 0, greater than 0 and less than 0. Okay. Now let us substitute the values here. If it is equated to 0, what would be the value of k? K will be 0 and 8. So 0 and 8 will be the two values for which k is equal, delta will be equal to 0. Okay. See, when k is equal to 0 or 8, on substituting k is equal to 0 or 8, delta will be 0. Delta is equal to 0. So this implies that the roots are real and equal. So for to get equal roots, k must take the value 0 or 8. Okay. And then to get the roots are real and distinct. They may be either rational or irrational, no problem. It should be real and distinct. For roots to be real and distinct, delta must be positive. So for what values of k it must be positive means, see, when k is below 0, that means it take negative value. So this is also negative and this will be negative. Negative value minus 8, this is minus 8 is negative, so it is negative. So negative into negative, positive. So when k takes the value below 0, it will be positive. Okay. And similarly, that is here it is positive. Similarly, when k takes the value greater than 8, here it will be positive into positive, again positive. So when k takes a value greater than 8, this is also positive. So for what values of k, delta will be greater than 0, positive quantity, when k is less than 0 and k is greater than 8. Okay. So when k is less than 0 and k is greater than 8, delta will be a positive quantity. So this implies that the roots are real and distinct. Okay. Now come to the third case. So here for these two values they will be positive and exactly at 0 and 8 they will be 0, means for when k takes the value between 0 to 8 it will be negative, delta will be negative. So when k lies between 0 and 8, delta will be negative. This implies that for these values of k, the roots are imaginary. Next, question number 4. Find a polynomial equation of minimum degree with rational coefficients having root 5 minus root 3 as a root. So you know that if root p plus root q is a root, means then root p minus root q minus root p plus root q minus root p minus root q are also roots of a polynomial equation. Okay, using that concept we are going to write down the other three roots, right? Given root 5 minus root 3 is a root 5 plus root 3 minus root 5 plus root 3 minus root 5 minus root 3 are also roots by the theorem. Okay. So with the help of the four roots we are going to determine the polynomial equation. So as it is of minimum degree means here we are going to get a quadratic polynomial as there are four roots. So first let us take two roots and find its factor, again take two roots and find the factor, and then let us multiply both the factors to get the required polynomial. So to get the factor using these two roots, instead of taking x minus root 5 minus root 3 and x minus of root 5 plus root 3 and multiplying, again we can use the equation Vieta's formula, that is sum of the root and the product of the root. Using that let us find out the factor. Okay. So let us take alpha to be root 5 minus root 3 and beta to be root 5 plus root 3. So let us name, for convenience let us name the root. Okay. So alpha plus beta will be equal to root 5 minus root 3 plus root 5 plus root 3, that is equal to 2 root 5. And the product of the roots, then alpha beta is equal to root 5 minus root 3 into root 5 plus root 3. So it is of the form a plus b into a minus b, that is a squared minus b squared, which is equal to 2. Okay. So what is the factor? So one factor is x squared minus alpha plus beta into x plus alpha beta. So just like the formation of equation, we can find out the factor in this way. So that is equal to x squared minus 2 root 5 into x plus 2. So to find the other factor using the other two roots, let us take for convenience one root to be some gamma, that is minus root 5 plus root 3, and delta minus root 5 minus root 3. Okay. So as usual, you have, in order to find the factor, let us find out gamma plus delta, that is sum. So gamma plus delta is equal to minus root 5 plus root 3 minus root 5 minus root 3. So that is equal to minus 2 root 5. And gamma delta, the product is minus root 5 plus root 3 into minus root 5 minus root 3. So minus root 5 the whole squared minus of root 3 the whole squared. So that is equal to 5 minus 3, which is equal to 2. So the other factor is, using the other two roots, we have found out the other factor as x squared minus gamma plus delta into x plus gamma delta, that is equal to x squared, then minus into minus, it will be plus 2 root 5 into x, then plus 2 plus 2. Okay, plus 2. This is the other factor. So when you multiply these two factors, you will get the required polynomial equation. So what is the required polynomial equation? The required polynomial equation is x squared minus 2 root 5x plus 2 into x squared plus 2 root 5x plus 2 equal to 0. So you have to multiply it and you have to give it as a quadratic polynomial. So how we are going to multiply this? Let us take this group this as x squared plus 2 minus 2 root 5x and x squared plus 2 plus 2 root 5x is equal to 0. So this is of the form. So, you have to multiply these two to get the required polynomial. So we are going to use the formula a plus b into a minus b, taking x squared plus 2 as a and 2 root 5x as b. So this will be x squared plus 2 the whole squared minus 2 root 5x the whole squared equal to 0. So expanding this, it will be x squared plus 4 plus 4x squared minus 2 squared is 4, root 5 squared is 5, 4 5 is 20, 20 x squared is equal to 0. So x power 4 minus 16 x squared plus 4 is equal to 0 is the required polynomial equation. So we got the quadratic polynomial. See, the remaining exercise problems are: second one, find a polynomial equation of minimum degree with rational coefficients having 2 plus root 3i as a root. So you can do this problem by you looking at referring the example. And also the third sum, find a polynomial equation of minimum degree with rational coefficients having 2y plus 3 as a root. So by taking its another root as conjugate, we can find its equation. So here 3 is the real part and 2y is the imaginary part. While taking conjugate, take care, okay, be careful while taking the conjugate. And then fourth one, prove that a straight line and a parabola cannot intersect at more than 2 points. This is just exactly like the example 3.14. So here you have to take the parabola equation to be the general equation y squared is equal to 4ax. And taking the straight line equation as y is equal to mx plus c, substitute and you will get a quadratic equation. Just like 3.14, proceed this problem, okay. See, this is example 3.14. Here finally we got a quadratic equation which gives two values for x. This means that for this the line and the circle cannot intersect more than 2 points, okay. But while getting the value for x, you may get either equal roots or distinct roots or imaginary roots. If they are imaginary values, then we may come to the conclusion that the line and the circle does not intersect. If they are equal roots, then it implies that the line is a tangent, because the equal root means only 1 point will occur. That means that the line touches circle at only 1 point. That means it is a tangent. And if they are distinct, real and distinct, two different values, means then we can say that the line is a intersect circle at the 2 points. That means the line is a secant. So while writing that example, I have written that the line and the circle intersects at 2 points, okay. But they may be either a tangent or a secant or does not intersect. So here it gives that two values. So the two values may be either equal or distinct or imaginary. According to that, it will be does not intersect, or it will be a tangent, or it will be a secant. So in general, we can say that the line and the circle cannot intersect at more than 2 points. So take it as the last line to be like this, okay.